Good day, sir. I am Chera Mistoso, BSEE 2B. In this video, I will discuss about what is thermodynamics and its application. On the second page, um, as you can see, before we proceed into the um, thermodynamics application, first I will define what is thermodynamics. Thermodynamics can be defined as study of energy. It is difficult to give a precise definition of energy, but energy can be viewed as ability to cause the change. The word thermodynamics is a Greek word which made up two different words. In that one term, another one is dynamics, where therm means heat, dynamic means power. In the brief thermodynamics, in the study of generation of power with heat, in the recent context, the definition of thermodynamic has changed. But in early 19th century, the motive behind study of thermodynamic is to generate power from from hot bodies or measure capacity of hot body to develop the work. And the third page, the application of the thermodynamics principle um, begins by defining a system that is in some sense distinct from its surroundings. For example, the system could be a sample of gas inside a cylinder with a movable piston, an entire steam engine, a marathon runner, the planet Earth, a neutron star, a black hole, or even the entire universe. In general, systems are free to exchange heat, work, and other forms of energy with their surroundings. A system condition at any given time called its thermodynamic states. For a gas in a cylinder with a movable piston, the state of the system is identified by the temperature, pressure, and volume of the gas. These properties are characteristics parameters that have been definite values at each other state and are independent of the way in which the system arrive at the state. In other words, any change in value of property depends only on the initial and final state of the system, not on the path followed by the system from one state to another. Such properties are called state functions. In contrast, the work done as the piston moves and the gas expands and the heat the gas absorbed from its surroundings depend on the detailed way in which expansion occurs. The behavior of the complex thermodynamic system, such as Earth's atmosphere, can be understood by first applying the principle of states and properties to its component parts. In this case, water vapor, and the various gases making up atmosphere. By isolating samples of material whose states and properties can be controlled and manipulated. Properties under interrelation can be studied as the system changes from the state to state. In the fourth slide, other application of thermodynamics. Here are some more application of thermodynamics. Excuse me. Sweating in a crowded room. In a crowded room, everybody or every person starts sweating. The body starts cooling down by transferring the body heat to the sweat. As you can see, in the woman and the woman is sweating. Um, the body starts cooling down. The body starts to cool down, and it will be converted to sweat. Sweat evaporates, adding heat to the room. Again, this happened due to first and second law of thermodynamics in action. One thing to keep in mind, Heat is not lost, but transferred, attaining equilibrium with maximum entropy. In the last slide or fifth slide, here are some examples also of more application of thermodynamics. Melting of ice cube. As you can see, melting of ice cube in the right side in on a glass of water with the ice cube, and then absorb heat from the drink, making the drink cooler. As you can see, if you will put an ice cube, the water will be slowly to be cold or colder. If you forget to drink it, after some time, it again attains room temperature. If you if you forgot it to drink, and then for the meantime or for after an hour or minutes, or it will back to the normal temperature before the temperature before you put an ice cubes. Um, all this happens as per the first and the second law of thermodynamics. Thank you for listening. That would be all.